Okay, this is called Reflections Day A. So these are all transformations, but they involve a reflection on each one. That's a reflection on the inside. That's a reflection on the inside. This is a reflection on the inside, and the one that's different is this one. That's a negative on the outside of the x. Now, how can you tell it's on the outside? Remember how I always tell you to put a little parenthesis where the x is? Just the x. That shows you that the negative's on the outside. Okay, otherwise, I do get why some kids think, wait a minute, Mr. Server, that negative's on the inside there. No, this negative is on the outside. Imagine there's little parentheses right where the x is. Okay, so if it's on the outside or inside, that tells you something. It tells you whether the reflection is left, right, or up, down. Everything on the inside is left, right stuff. This is both left, right stuff, the for and the negative. Left, right. This is left, right. This is left, right. And there's nothing going on left or right in this one because there's nothing on the inside except the x. So all these changes here, the 3 is on the outside and therefore up, down. This 7 is on the outside and therefore up, down. This -5 is on the outside and therefore up, down. All right. I would like, since I reminded you of all of that, should be pretty easy for you now to list for me what all the changes are for each of these things. Like, not necessarily in any order, just tell me what are the two things that happen to this. It's got a reflection over the certain axis. You figure out which one. If it's on the inside, you should be able to tell that it's a left-right thing, and therefore it's over which axis. And then this one's moving up 7, for example. Okay, write that for each of these functions. I'm going to pause while you work on that. Okay, had enough time to work on that? Number 1, Maddie, what did you say the two things were?
I said
buying time, yes. Okay, reflect over y. Now that seems to me like it's, this is the y-axis, right? That seems to me like you're saying it's a left-right flip. Do you still want to say that?
Yes.
Good, you're right. And then the second thing?
Up 7.
You are correct. Okay, moving on to the next one. Mr. N in the checkered blue shirt. The g of x one, what is that?
Reflection over the y.
Over the y? Are you sure about that?
Yeah.
Good, you're right. And then?
Left 4.
Left 4. All right, awesome. Doesn't it seem like it should be right 4? How come it's not right 4? In the inside, and so you do the opposite. Very good. On the next one, let's go with Andrew.
Down 5.
Down 5. And why is this, wait a minute, it's in front. Shouldn't that be like a flip or something?
No.
Because it could be in the back just as easy, couldn't it? -5 just as easy right there. Okay, so down 5 is good. And then what's the other thing?
Over the y.
Reflect over the y. We will eventually reflect over the x, which implies on the next one, go ahead. Yes, you. Reflect over x. And why is it over the x? Because it's on the outside of the function. See, that's on the outside. That's the inside. Nothing going on the inside. And then what's the other thing? Up 3. You are very right. Okay. Anybody have them all right? Good. Now you can be good at that part and still get a terrible grade on this test that's coming on Thursday. Just so you know, because it's one thing to know which way the thing should go, and it's another to actually make the graph move there correctly. Okay, and some of them can get very confusing. We're starting with a fairly easy one here, and I did skip over an important slide. Even though there's a better way to do this in pre-calc that you will learn, for right now, this is a simple trick that always works. So I'm going to tell you, if you do your reflections first, okay, then you do your other stuff, then your translations, it will work the best if you put reflections first. Now, that's a very simplified, anybody who knows the rules from pre-calc, you know it's much more complicated than that. I'm saying that disclaimer for teachers or whoever's listening, but it is very easy if you just do your reflections first. Okay, so you agree there's a reflection involved in this parabola? Okay, so you're, first of all, hopefully you know where the parabola is. And generally speaking, parabolas, kind of look like this. If you wanted to be sure, you'd have 5 important points. But there's my parabola, and I should reflect it first. Which way, left, right, or up, down? Up, down, because it's on the outside. Notice There's nothing on the inside with the x. Okay? Then, if it's up, down, flip, it should look kind of like that. And then the last part is what? Minus 5, which means what? Down 5. There should be your answer. Raise your hand if you were in the right neighborhood for that. Okay. Now, this is really important, what I'm about to tell you here. If you want an A on this test, if you really care a lot about the A versus the B, because remember, you can get a free mistake on the front side and a free mistake on the back side of your test and still have an A. But you make one more mistake, now you got a B. Okay, big difference in GPA, big difference on how you feel about how you're doing in the class, right? So all it would take is one mistake on this to get it wrong and to get the whole test down to a B. So my point is, if you really care and there's only 8 questions, you probably have time to check them. Mr. T, could you shut that door, please? So I'm going to tell you about a little way that you can be absolutely sure you've done it right. It's called the XY chart. So here's how this works, and I'm telling you, this will work in pre-calc also. Anytime you ever have to make an important graph, this way works. You stick in any number you want, and might as well pick nice easy ones, like 0, 1, and 2, into this graph. Everybody make an XY chart, just like I just did, on the side of this graph. And now, I'd like you to pick an easy number for x. Remember, x's are this way. Do you think picking 10 makes any sense? No. You'd probably pick a number in this kind of zone right here, right? So how about 0? Isn't that a good number? I agree. So let's put in a 0. We put in a 0 right there. 0 squared is what? 0, and then negative 0 is still 0, right? And then minus 5. What's the answer? Minus 5. 0, negative 5. Do you get that 0, negative 5 is on my graph? If I had by accident, do you get that a lot of kids are going to by accident move the wrong way? It happens all the time. You probably haven't graded a lot of math tests, but all it takes is for kids to go, oh, up versus down. You know, a lot of kids are going to go up there by accident. And if they have graphed this 0, negative 5, and they go, okay, so 0, negative 5 is supposed to be on my graph, you get they're going to go down here and go, wait a minute, either I graphed it wrong or I just put that point in wrong. And then they're going to look back at it and go, oh, wait a minute, it's down 5. I should have it down here. You check yourself before you wreck your grade. All right. Yes, I know. Isn't there some rap song, check yourself before you wreck yourself? I don't know. Anyway. So I'm going to try putting in 1 for my x. Now, if I put a 1 right here, do it in your head. Remember, the squaring happens first. Then the negative gets applied. What do I get? Negative 6. Now look here at 1 over 1, down 6. Look at, wait, I'm off. Right there. Do you get that even though my graph's kind of in the right place, that it really wasn't graphed very well? It was too much of a sketch. Like I kind of generally am in this area, but I should have been much more careful with that. My graph should go more tight like this. That black graph was really too loosey-goosey. All right, what else can I put in? Like, how about 2? Everybody put in 2. Turn it my way when you have 2 comma something. I want to see what you thought it was. You're right. You're right. You're right. You're right. Is that a cell phone? All right, that goes on my desk. You're right. 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 Yes, thank you. Okay. 2 comma negative 9. All right. I want to make the point here that you don't even have to do these graphs with the, oh, I know what the parent looks like, then I'm going to move it and flip it and blah, blah, blah. You can just take the graph like this and make an XY chart for it and know exactly what the graph looks like, even without knowing that, oh, I moved it 2 to the left and down 5 and flipped it and all that stuff. So I'd like you to just put in some numbers for X and Y. Sorry, just for X. And you'll figure out what the Y's are. You can pick any numbers you want, so why don't you pretty much always pick 0, 1, 2, maybe throw in a small negative number like negative 1. So specifically, if I was picking, I'd always pick those 4 numbers. Pretty much. Unless I knew that the graph was way over off the, like been moved a lot from normal. So don't even graph this. Just tell me what the points are that go with it. If I put in a 0, okay, Zoe, walk me through this one. If I put in a 0, what happens? And then I get, okay, good. 2 squared is 4. Good. Then what? Now it's negative 4. Okay, all that's negative 4. And then what? And you get negative 9. 0 comma negative 9. How many of you had that one right? Okay, good. Mr. A, turn yours my way. All right, thank you. You just made it disappear by accident. All right, can you put in the 1 for me and tell me what you have? Okay, wait. Try again. Look up here. 1 plus 2 is 3, and then makes, and then you make it negative 9 and negative 5 together, negative 14. Good. All right. Moving on. Mr. N. I guess I can say first names. Noah. Yeah, you're right. Noah, what did you get for sticking in a 2? No, wait, a negative 1, sorry.
Negative 1 was 1. 1 squared.
1 squared is 1.
Then negative 1.
Negative 1.
5, negative 6.
Negative 1 minus 5 is negative 6. Good. Did we ever put in 1? And I didn't write down the answer? How about who has it? 1 goes with what? So that means you get somebody else. What do you got? Negative 14. Was it? Was 2 also negative 14? What was 2? 2 is negative 21. Can anybody verify that? You got that same thing? Okay, good. All right, good. That's where I messed up. All right. So now, if I graph these points, I have got part of my parabola. But let me tell you what the most important part of the parabola is, and it's the vertex. Let me show you how to get the vertex. It's really a smart thing to know. Do you get that if I make this whole thing equal 0, that would be pretty slick? What number could I put in that would make that whole thing equal 0? Negative 2. Because negative 2 plus 2 will make 0. 0 squared will be 0, right? So negative 2 comma negative 5. Do you get how I just got the vertex of that? That is probably one of the most important points, because wouldn't you agree, if you look at the graph on a parabola like this, isn't that probably the most important point? It's where it's making the turn. Okay, how about on the V shape, also known as the absolute value? Would you agree that that is probably the most special point of them all? It's where it makes the turn. There's no other point like that on the whole graph. Okay. How about the spot of this graph, which goes on forever? Wouldn't you agree that spot right there is probably the most important point? Okay, those spots are important, and you can find them this way. It's whatever makes this 0, and then when that does become 0, the answer will be 8. So if I'm making an XY chart, what should be a no-brainer point to put in? X is what? 3. And then what will Y be? You see how it's the easiest point to figure out, too? Because that whole thing becomes 0 as soon as you put in the right number. So 3 comma 8. So what is that? That's the vertex of a parabola. I know it's a parabola because it's got a squared there. All right? Tell me where the vertex is. That's a minus 5 in there. Got a little sloppy. What's the vertex on that one? Don't say it, write it, turn it my way. Something happened. It just says I can't read it. There we go. All right. Yes, sir. Yes, yes, yes. Yep, 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 yep. Too much glare. Yep. Although, is that right number? A 9? I couldn't read it. Yep, yep. Yep, 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 yep. Okay, good. Pretty much everybody's getting this. What's important? You put in a 5. That makes this equal 0, and then you get 5 comma 9 is your point on the XY chart. All right. That's the what? That's the vertex. It's the vertex of the V shape. It's probably the most important point to put. All right. Enough of that. Now let's actually just graph this. Take a second. Tell me where you think it, like, oh, it looks like they're moving it to the left 1. Looks like they're flipping it. Looks like we got a -2 there to deal with. Make me where this graph should be. And then if you really care that it's right, you should check it by using an XY chart, like I just showed you. Again, you could start by doing the parent square root, which is like this, and that works fine, and then you do move and flip and blah, blah, blah. But you don't even have to do that. If you're going to do an XY chart anyway, you could just make your XY chart, find all the points, and graph them. Or you can graph the parents and then move them all a bunch of different weird ways. To me, honestly, on a complicated problem, I think it's easier to just start with the chart. Start with the XY chart. All right. For those that got confused by this language, I'm going to rewrite it for you. It's a square root problem, and it has been moved. I use y instead of f of x, but f of x is the same thing as y, so y equals, and it's got a square root of x, but it's been moved. +1 means +1 on the inside, and then it's got a -2 on the outside. That means it's going to move down 2, and then there's one thing missing I haven't done yet according to my directions. Yes, sir. Yes, negative on the outside right there. That negative on the outside should be a negative right there. That's rewriting the function. That's a typical test question, is just rewrite the function. This one, I actually asked you to graph it. So now, my best advice on a complicated problem is don't go graph the parent and try to move it. It's too hard. I make mistakes on this all the time. All it takes is to move it one too many in the wrong direction, and everything's going to be wrong. Okay, you can do this if you really want to. You can take this and then move it. Let's see which way. It's going to be left 1, and then I'm going to have to do a bunch of other stuff to it. You can do it that way if you want. Or you can make the XY chart for it and graph the points that come up. You do it either way, and then tell me what you think the answer is. I'll pause while you work on that. Okay, so here we are. Here are some points that should be on your graph. I suggested you test 0, 1, 2, and maybe -1. All right? So I'm going to ask a few people to give me their scores. In fact, actually, just turn them my way and let me see if you've got them right. All right, here's what you should have actually had on the chart. When you put in a 0, 0 plus 1 is 1. Square root of 1 works out nice. Square root of 1 is 1. And then I make it negative, so now it's -1. -1 minus the 2 makes -3. Raise your hand if you had 0 and -3 on yours. Okay, good. And then a 1. Is that really going to turn out really well? No, because 1 plus 1 is 2. And all of a sudden, I've got a square root of 2 happening. All right? I'm going to instead jump down to the -1 option. -1 plus 1 works out nice because it comes out to 0, and square root of 0 is 0, and then you get -2. -1 goes with -2. Do you notice that my key points, these two, both wouldn't work out nice? Because one comes out to the square root of 2, one comes out to the square root of 3, and I don't know what those are, so you probably don't either. So at least these two would have been logical choices. Now, if you did it with the graph it and move it and flip it method, you should at least know that that point should have been on your graph. And at this point, -1, -2 should also be on your graph. Now, if I know that the parent was like this, and it's been moved to the left 1 and down 2, do you get how it goes to the left 1 and down 2 and it's right there? But there's one more thing. It's being flipped, right? Up, down, flip would make it upside down, and so generally speaking, I know your graph should look like that. Raise your hand if yours was in the right spot. Okay, good. Now, a lot of people's wasn't. And I know that. And you should have been able to tell it wasn't in the right spot, because you should have checked these two spots, these two red points. If you checked them, you'll make sure that you didn't put it in the wrong spot by accident. So that XY chart checking is really important. All right. Next one is I draw a function and you tell me what the equation is for it. Here is a function. I'm going to keep it fairly simple. Tell me what equation that one is. It's got a parent, it's been moved. Should be able to write a new equation for that. Would you agree it's been moved right 1 and up 3? So that should be a big hint on what your equation should look like. All right, this time instead of showing it to me, I'd like to do this way where you turn and show you two are going to have to share him. Okay, you're going to go this way. You're going to go this way, except you will have to look at the person in front of you because there's nobody right to the right of you. Okay, these two rows and these two rows, except a couple people will have to share. You two are going to have to share him, and you two are going to have to share her. Okay, go. Check. Make sure you did them right. If you're different, let's just try to figure out between talking about it who's right. How many of you were the same as your person? Okay. And there's a few people that didn't raise their hand, so then obviously there's some people different. Let's see who was right. You're supposed to write the equation. First of all, if you forgot the y equals, you will lose this credit. It's so painful because it's such a simple little thing to forget, and yet you will not get credit unless it says y equals. Okay, next part is, I have to have a square root because that's what the parent is, right? And then there has to be an x inside that. But that would imply I hadn't moved it at all. But this one has been moved. It's been moved 1 to the right, minus 1. And then it has not been flipped at all. The only other thing is it's been moved up 1. Which, no, up 3, sorry, there we go. That should have been your answer. Okay, any questions? Yes? Could you move that to 3 plus in the front? Yes. We usually do it the way I wrote it, but you can do it that way. It's legal. It's okay. All right. Moving on, I want to do one more like that. This is going to be an upside down parabola. Right there, and there, so it goes basically like that. Write me an equation for that one. This test again is coming on Thursday of this week. Pause for a second while you work on that. Okay, you should have said y equals x squared, except that's just the parent, right? Now, what things happen to it? Give me one thing, Mr. V. Okay, so I'm going to go minus 1 on the outside. Okay, give me something else. So how do I do that? Negative is where? On the inside or outside? All right, excellent. And the last thing, Miss T. I'm sorry, I said it wrong. I still pointed at you, so go ahead. Sorry, it's L, but anyway. 4, what kind of a 4? Minus 4 or plus 4? Plus 4. Raise your hand if you had that same thing on your paper. Okay, good. Your virtual paper. Last thing is domain and range of this function. Do you remember how to do this? If not, there goes a point and therefore probably a whole grade. Because you're going to make a stupid mistake. Just count on it. If you don't know a concept like this, you're probably going to lose another point and therefore go down a grade. Okay, domain is left-right. Range is down to up. Remember they look like this? Except sometimes there's brackets. Your bottom one's messed up. Your top one's good. A lot of people mess up the bottom one. Yes, 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 yes. Lots of people getting it right and rejoicing in the streets. The bottom one's wrong. Yes, bottom one's backwards. Well, actually, wait a minute. The bottom one might have been, turn it back my way. Can you zoom in on it again? Okay, that's right. Sorry about that. No bracket on the infinity. Is that a negative infinity? I can't tell. Then you're right. Good. Okay, domain, negative infinity to positive infinity. That one's pretty easy. It goes forever this way and forever that way. Remember that the range is down to up. What's way down here? Negative infinity. What's way up, the highest it ever goes, is -1, and it needs a bracket right there. Now, I had some of you, I think, when I was doing it, I said it slightly wrong. I said you were right when you weren't, but there it is. Most people had it right. Okay, moving on. Oh, good, that's it. Reflections, Day A is your assignment. I looked at it, it's fairly smallish. It's not even nearly as long as last night's, so it's very doable. Please get your homework done. I am putting that in the grade book, and it does make a big difference on your grade. Don't lie to yourself and act like it doesn't. It does. And you hate to give up GPA points. You know, the further you make it in high school, you'll realize, crap, if I would have just tried a little bit harder in the math class, it could have been easily an A instead of the B that I got. And those GPA points are tough to get back when you're like a junior or a senior.